Hello class. So we've worked on odd and even functions with graphs and tables so far. Now we're going to look at how we can use those applications that we've seen before to apply it to with equations or functions. So when we were working with tables, we learned that for an even function, if we have an x and y value, then our negative x value has the same y value. And when we're working with odd functions, and if we have the opposite x value, we have the opposite y value. What we're going to want to do is transfer this into function notation. And for that, what we can do, our y value is f of x with x being our x here. The whole f of x here is our y. Okay. So, with our even functions, this will pop back up. Our f of x, so when our y value is going to be equal to y value, so we're still going to have this, our f of, it's our y value coming out, except our x value is going to change to a negative. So we'll have our, I guess I could rewrite that a little better. Okay, let's try that again. But we can use our values from tables to find that f of x is equal to f of negative x. The f part coming out, that's our y value. What we're plugging in, what's on the inside, is our x value. So with our odd functions, our x value and our y value are changing. So and this is going to tell us, my mouse will stop fighting me, is that if I plug in f of negative x, my y value will switch to. So when working with even functions, we have f of x is equal to f of negative x. And for our odd functions, we have negative f of x is equal to f of negative x. All right. Let's kind of see how we can apply this. So if we have an equation and we want to determine whether the function is odd or even, what we can do is this is our function if we plugged in x generally. That's what's usually given to us. What we can do is we can plug in negative x, okay, wherever there's an x value, we're going to replace that with a negative x value. Plus okay. Now, as a quick reminder, if you don't remember, if we have a power or a negative number, why don't we just use an actual number for this instead of a variable? So say we have, okay. So let's say we have a negative number, say negative 2. If I raise this to an even power, say I square it, negative 2 times negative 2 will give me a positive 4. But if I have negative 2 to a negative power, then we have negative 2 times negative 2 times negative 2, which will give us a negative 8. So as a general frame of reference, if our power is even, so if I have, if I have an even power, then the solution is positive. Ooh, that's some terrible spelling there. Okay. And if we have a odd power, the laptop is fighting back today. I'm not sure what's up with it today. So if I have a odd power, the solution keeps its sign. So for with us here, -2 squared, since squared is an even powered, solution is going to be positive. If we have -2 cubed, then our solution keeps its sign at -2. And just to show with another odd power, say I had 2 to the 5th power, we'd still have 2 times 2 times 2 times 2 times 2. Give us 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 would give us 32. So when we have a odd power, the sign stays the same. If I have a even power, so this would have been -2 times -2, these odd symbols are going to cancel out, because negative times negative is the positives, right? So if we have an even power, solution's positive, odd power, keep the sign. Okay, so that how here is for our g of -x. Our -x to the 5th is equivalent to -x to the 5th. Because we're going to keep the same power, or the same sign, because the power is odd. Same here. I could bring that negative out. Since our power is odd, the solution will keep the sign. And -x is just -x. Now, let's compare our answer here with our original. So when I plugged in -x here, negative. See how all of the signs turned from positive to negative? That is telling us that if I plug in -x, I get the same function back, but negative. Say it again. Since all of the signs on the inside here change to negative, that's the equivalent of multiplying the entire function by a -1. It's a little difficult to see. We can show why here. So g of -x, all of our signs changed, which is equivalent to multiplying the entire equation by -1, but let's just multiply the entire equation by -1 to show it. So if I originally have g of x is our x to the 5th plus x cubed plus x. If I were to multiply both sides of this equation by a -1, so I'm going to multiply by -1 on this side and by -1 on this side. All multiplying by -1 is changes our signs. So we have negative g of x is equal to -1 times x to the 5th power would be negative x to the 5th power minus x cubed times -1, so negative x cubed, And x times -1 will give us -x. Do you notice how this here, these two are the same? Our g of -x and our negative g of x. Since our g of -x and negative g of x are the same, let's see the rules we found defined earlier. Those are the same, then our function is odd. So our function here is odd. Okay? So what we need to do when we're trying to figure out if a function is odd or even, plug in -x instead of x. And then we look at what that does to the equation. In this case, it changed all of the signs to a negative. So that's the same thing as our -1 times g of x or negative g of x. Okay, let's do another one. So we have a function, and we want to determine if it's even, odd, or neither. So we take our f of x, and we're going to plug in -x. The reason we're doing this, we want to see if we can find either of these patterns. If either of these patterns come up, we have an odd or an even function. But if neither pop up, then it's neither. So let's take our -x here. We'll even make it red. Take our -x, and replacing all of our x's with -x. So we have 8 times -x cubed plus 4 times, ooh, laptop is fighting me, -x. Okay. So we have our negative raised to an odd power. So I can take out the negative because the sign's going to stay the same with our solution. So we have f of -x is equal to, bring out our negative. So we have negative, we still have our 8, and then x cubed. Okay. -x times 4 will give us minus 4x. I want you to notice something. See how all of our signs change from a positive to a negative? That's the same pattern we saw with the last one. So our f of -x function is equal to our negative f of x function. And we're done. Since we found a pattern, we know that this is going to be an odd function. Alright. We have negative f of x is equal to f of -x. That's our pattern. We found it. Once again, when we're trying to determine if a function is odd or even, plug -x into our function. If we can find either of the patterns, it matches either if it's an odd or even based on the pattern. If it matches neither of the patterns, it's neither. Alright? I want you guys to try this one. Plug in -x and see if we can find one of those patterns. Give you a second to try it out, and then we'll go over it. Okay, so hopefully everyone got a chance to try it. So when I plug in my f of -x, we have -x raised to even powers here. Our even powers, our solutions are going to come out as positive. So we still have -5 stays the same, times, these are going to be positive, we can just get rid of our negative. So I have -5 times x to the 4th, minus 2x squared plus 4. Since these powers here are even, it'll give me my color. Oh, well. There it goes. Nope, gave me red. I want. There we go. Since these powers are even, just like we covered earlier, the sign is going to stay, oh, did I not circle it? Since these powers are even, this is going to be a positive answer. Just like if we had negative 2 squared, it's the same thing as 2 squared. Or say we had negative 4 raised, why not to the 8th power? That's the same thing as, I did not write it, to the 8th. If it's an even power, the negative's going to be going away. So, if I plug in negative x, we get the same equation back. So it's equal to f of x. And remember from earlier, our pattern, if f of x is equal to f of negative x, we have an even function. Alright, let's do one more. Give this a go. Plug in at negative x. See if we can find any of those patterns. Okay? We all had a chance to give this a go. If I plug in negative x, we have one odd power here, which means our negative is going to come out. And we have one even power, so our negative is going to go away. So notice something. Not all of the signs changed, and not all the signs stayed the same. So this is going to be neither. Because neither of our patterns came out. So remember, our patterns is that our two equations are exactly the same as we started, or all of the signs changed. Because that's what negative f of x is. So, since some of the signs changed, but not all of them, neither pattern popped up, so we do not have a odd even function, so it's neither. Now, last thing we're due for today is we're going to try this with one of the functions that I did earlier, in one of the previous videos. No, it's not this one. Where are we at? We'll do this here. Okay, so let's look at our second function here. We have y is equal to x cubed minus 3, which is the same thing as our y is just f of x. We have f of x is equal to x cubed minus 3. If we plug in negative x, we'll have f of negative x is equal to negative x cubed minus 3. Since we have an odd power here, our sign is going to stay the same here, so we get to keep it. So we have f of negative x is equal to negative x cubed minus 3. Notice how some of the signs changed, but not all of them, so it'll be neither, just like we got with the tables and the graph. Okay? Similar for y is equal to 2. This is, if we have f of x is equal to 2, if I plug in f of negative x, that should be blue, is equal to 2. Well, if I replace all of my x's with negative x, we still just have 2. So, none of my, so it's going to be an even function, just like we found with our table and our graphical method. All three methods work, it's just based on what information we're given, on what we can and can't use. Here we go. So, as a quick review, even functions. If I plug in f of negative x and we get the same function back, none of the signs change, it'll be an even function. For our odd functions, if I plug in negative x and all of the signs change, then we have an odd function. The way we say that for function notation is f of x is equal to f of negative x for our even functions. And for our odd functions, we have negative f of x is equal to f of negative x. All right. Hope you guys have a great rest of your day.